So what are the two types of symmetric algorithms? Two types of symmetric algorithms. That's block and stream. Remember that block takes a message, cuts it up into individual blocks, encrypts those one at a time. Stream will encrypt one bit at a time because the algorithm's creating that key stream. And asymmetric, the two types of mathematics that are used are factoring large numbers and discrete logarithms in a finite field. So these are things that you need to know, and we're actually going to build on top of these concepts. So we've looked at some asymmetric algorithms. We looked at how Diffie-Hellman works, how RSA works, and El-Gamal. Now we're going to look at some symmetric algorithms and how they work and how one's different than the other. Now, data encryption standard, DES, was used for 20 years. It was had a long lifetime. It was used to encrypt sensitive but unclassified data within the government. Again, it was used to protect sensitive but unclassified data. And what's, something kind of funny is when I first was writing my book, the all-in-one book, the first edition, when I was writing about these algorithms and I got to DES and I said that it protects sensitive but unclassified data, and I kept wondering, well, what algorithms are used to classify or to encrypt classified data? What algorithms are used to encrypt secret data or top secret data? And I studied and I studied and studied, I researched and read all these books, and I couldn't find, what's actually used to classify more sensitive data within the DoD. So I actually emailed one of the authors of an encryption book, and I asked him that. I said, I see that this is what DES is used for. What are the other algorithms that are used to encrypt top secret data or secret data by the government? And his reply to me was very simple. He said, I don't know and you don't know. And then I got it. Because DES is known about because it's going to encrypt unclassified data that can be available to the public. Their secret, top secret, and other layers of classification are encrypted by their own algorithms that are developed by their own cryptographers, and we don't know anything about it. And that's how they want it. So DES was developed specifically for this purpose. Now, in the 60s, 70s, the United States government was pretty freaky about encryption. They didn't want anybody to have encryption capabilities. And the reason is because the NSA's job is to, watch traffic, figure out if somebody's going to try to do something to the nation. And they couldn't actually break some level or some types of encryption. So, people didn't have encryption at a certain time. It wasn't in all the software like it is now. And what it's kind of interesting about DES is that there's a gentleman that wanted to practice in cryptography. He came, I think, from Germany. He was working at one university, and the government put pressure and shut his work down. He went to another place, and the government wasn't necessarily after him. The government just didn't want encryption to be built so it can get into their enemies' hands and they can't snoop in on the traffic. And then this guy went to IBM, and obviously IBM had a lot of push and a great relationship with the DoD. So this guy comes up with an algorithm that is DES. He created, with a team, I'm sure, DES. And so it's very ironic that the United States government kept saying, you can't do it, you can't do it. And once they just let him work, he created the algorithm that was used for 20 years. Now, what happens when a new algorithm is needed, the NSA and NIST get together and lay out the requirements. And then, they publish the requirements. Then all the different companies and cryptographers come up with their algorithms. They submit them to the NSA and NIST for testing. And then one algorithm is actually chosen for this standard. So DES actually stands for Data Encryption Standard. It's actually a standard. The algorithm that was accepted for DES is called Lucifer. So the guy who actually created at IBM with his team, he created this algorithm. It was called Lucifer. That was the one that was accepted. Now that algorithm had a key size of 128 bits. And at the time, the NSA knew that it didn't have enough processing power to break anything encrypted with that size of key. So they took the Lucifer algorithm and reduced the key size to 64-bit and renamed it Data Encryption Algorithm, DEA. So the actual algorithm that fulfills the standard is DEA, Data Encryption Algorithm. We just call it DES. We just call it by the standard. Now I point that out because you could see questions on DEA and you'll be like, I have no idea what that is, or it'll be spelled out, Data Encryption Algorithm. Data Encryption Algorithm is DES. They're really the same thing. So the exam has hit DES a lot, but now it's going more towards its replacement, which we'll talk about, which is AES. But there are specific things that you need to know about DES.